Hi, this is Owen Astracan with videoO, Sorting with APIs for CompSci 201, academic year 2021-2022. O is for object-oriented. We've seen that Java is an object-oriented language. We design things with both inheritance and interfaces. O is also for O notation, the notation we use to understand asymptotic runtime complexity as well as other complexities. O is also for open source. That has to do with copyright, who's created something, and the Creative Commons. We are using an open source distribution of Java in this course, and it's used in many other courses. How will we understand sorting, and how will you understand sorting? To solve most problems, you will use arrays.sort or collections.sort, the built-in sorting library that allows you to sort almost, but not quite everything in Java. You'll need to specify, or you'll be able to specify, how elements are compared with each other when they're sorted. And that will use both a comparable and comparator interface that I'll explain in this video. Why do we use the API? It's general, it's extendable, it's modifiable, and it's very fast and very well engineered. And we'll see that when we study sorting algorithms, including briefly the one used in Java. What can be sorted in Java? We've already seen that we can call arrays.sort with a string array and collections.sort with a string array list. But the point class that we investigated in an earlier video with both a simple point and a robust point cannot be sorted if we try to either sort an array of point objects or an array list of point objects. We'll get an error message like the one shown here. Class robust.point cannot be cast to java.lang.comparable. And we'll see that in Java, you can sort things that are comparable. You have to specify how to compare the elements, either because the elements are already comparable, because remember that in object-oriented program, we ask what the object can do to itself, and the object will know how to compare itself. And when we can't ask the object to compare itself to another one, we can tell it how to. Not everything is comparable. For example, that point class we just saw is not comparable. There is an interface, java.lang.comparable, and implementing the interface requires a method named compareTo. And we'll see in the next few slides how that works. With primitives, we can simply use equals equals, not equals, less than, greater than, less than or equal to. But just as we can't use equals equals with objects, we had to use the dot equals method. We can't write apple less than zebra for the strings apple and zebra. We must compare them using an analog to dot equals, and that analog is dot compareTo. So we can write ant dot compareTo bat. And what we'll see is that the result of the compareTo method being applied to two objects is a number less than 0 if the first one is less than the second, a number equal to 0 if they're the same or equal, and a number greater than 0 if the first object is greater than the second. So in the example of ant.compareTo bat, we'll treat that as -1 because ant is less than bat. Now, because string implements this comparable interface, in fact, in particular, string implements comparable string, we can write hello.compareTo goodbye, and because A, B, C, D, E, F, G, H is bigger, that's a value larger than 0. We don't know what the value is, just that it's bigger than 0. Integer also implements comparable integer, so we can write, as we see here, new integer 3.compareTo new integer 5. That's a value less than 0 because 3 is less than 5. Now, although we can compare array lists with dot equals, we've seen that before, we cannot compare array lists using dot compareTo. The array list class does not implement the comparable interface. With strings, the ordering that's used is sometimes called a natural order or a dictionary order, or even a lexicographical order. It's the order in which you'd find strings in a dictionary, except that it turns out case is important for strings. So although conceptually little z zebra is greater than little a aardvark, it turns out that big Z zebra is less than little a aardvark because capital letters come before lowercase letters in either Unicode or ASCII. We'll use, however, the compare to method. So we can see here, we can write yak.compare to s, and as just explained, that will be a value, say, less than 0 if s is zebra, because yak is less than zebra, equal to 0 if s is yak, because yak is equal to yak, and greater than 0 if s is toad, because yak is bigger than toad. Now this same integer convention of less than, equal to, or greater than 0 is also used in C++ and in C, so it's common across other languages. If we wanted to make that robust point class comparable, we'd say it implements the comparable interface angle bracket point, because comparable requires a type. So we could write point implements comparable point, and then our IDE might say, you can't do that without implementing a specific method. And so we'd implement the method, and we see here that the signature is public int compare to point. Just a reminder that for compare to, we know the type. It is the same type as the class where we wrote point implements comparable point. Recall that for .equals, the parameter type was object. Well, that's because equals is inherited from object, but object is not comparable or comparable. So we'd have to implement this method with that signature and return a value appropriately. Here's one way we could do that. We could cast the difference of the x's to an int. So we'd subtract them and use dx as that difference. And if that was not 0, we could simply return it, because then a negative number means that my x-coordinate is less than the other x-coordinate. Otherwise, we could return the difference in the y's. And we see here that the 2 points, the point on the left, 1, 65, is less than 3, 224, because their x values are different. And the point 4, 137 is less than the point 4, 517, because although their x values are equal, the y value on the left is less than the y value on the right. Now there's more than one way of writing this compare to method. We could look at the difference and see if the x is less, return a negative number. If the x is greater, return a positive number. And if we reach what's highlighted here, we know the x's must be equal, because otherwise we would have already returned a value. And so we compare the y values and return a corresponding negative or positive number. Now this assumes we have access to the point class so that we can modify the source code to implement comparable point. But sometimes you may not have access to the source code, or you may want to change how the default compare to works. For that, we use another interface, java.util.comparator. And we'll have to read the API for more details. And there are many methods that we can use in implementing this interface. What we'll see is that we can sort an array of point objects by using a comparator that we specify. First, we compare by using the x-coordinate, and what we see as the argument in the comparing method is point : get x. That's a function in the point class. Get x was a method in the point class, and if two x values are the same, then we'll compare with the y value. So this reads, as you can see in the one-line version, comparator.comparing point : get x dot then comparing point : get y. Now the syntax will take a while to get used to, but the key is we are using the dot comparing method of the comparable interface. So comparator.comparing and then dot then comparing. And we'll see more examples of this later. Why are we using array.sort or collections.sort? Because first, it uses an incredibly fast and efficient and good sorting algorithm, timsort. When we study algorithms, we'll see it's fast, it's stable, it's good. And we can configure it with these comparator interfaces. Now, although we just looked at arrays.sort and collections.sort, it turns out that there is a sort method for the ArrayList class as well. And we can see here that I can say a.sort, but I must specify how to sort when I do that. And I'm saying here comparator.natural order. And this will give me capital C, BZ, because capital letters come first. We'll see more examples of this, but this is enough to get started. When we are using a comparator, we must provide a method named compare. It has two parameters, thing A and thing B. That's assuming that my class is named thing. It's similar but different from a.compareToB for the comparable interface. For a.compareTo B, B is passed as a parameter to the method for A. So I have two objects, A, which is this, .compareToB. For a comparator, I supply both objects. Here's an example. I'm going to have an array of strings, and first I just make a copy and print it. And you can see I have zoo, lemon, apple, ant, yesterday, buzzard, onomatopoeia. If I sort that array, and that just sorts by the natural ordering, and then print it, I get ant, apple, buzzard, lemon, onomatopoeia, yesterday, and zoo, because the natural order is alphabetical. If I sort it by using comparator.comparing and then provide a method, string : length, that's a method of the string class, now it sorts by length. So I get zoo, ant, lemon, apple, buzzard, yesterday, and onomatopoeia, because I'm sorting by the lengths of the string. That's why arrays.sort and collections.sort are powerful. We can change how it sorts by just providing a method to the sorting function. We can also create a custom comparator. In this case, when I don't have one method, I'll write the method. So I have a class fruity here. It implements comparator string. So I must supply a method compare with two string objects. And what I'm going to do in this method is say any fruit is less than something else. So if we see here that if something is a fruit, if O1 is a fruit and the other one is not a fruit, I get a negative number. Or what's highlighted says if the second thing is a fruit and the first thing isn't. So O2 is a fruit, O1 is not. Fruits are bigger. Otherwise, I compare the two things naturally. So what we see here is when we sort this array and we use the fruity object, so we say arrays.sort new fruity, what we get is apple, lemon, ant, buzzard, onomatopoeia, yesterday, zoo, because fruits are less than everything else. I might have said fruits are bigger, but fruits are less than everything else. So we get the fruits first and the other things next. This is Lynn Conway. I hope you will read the Wikipedia article or see her website at lynnconway.com. She joined Xerox PARC in 1973, and she revolutionized VLSI design. But she'd already revolutionized dynamic scheduling in the 1960s working for IBM. And then she realized she was trans and she was fired from IBM, underwent a transition, and as a woman has made incredible contributions to computer science. And she says, we've come so far, so fast, that ever so many others could begin shedding old habits. After all, freedom isn't just an external concept framed by our laws. It's a gift of the spirit that we must give ourselves, in this case by going toward brighter shades of out. Bottom line, if you want to change the future, start living as if you're already there. Be a change agent. Enjoy your life.